the world of math.
Isn't it something like
Okay, output? How'd you come up with that?
general percentage?
Oh, and the arrows kind of do something about that? All right, there you go. And that's in fact what I want you guys to write so far. There's a couple words that we need to know. And it's not just one input, it's lots of inputs. A domain is a set of inputs. And the range is a set of outputs. Kayla, do you remember anything else the domain was called? Okay. Well, if I have inputs and it goes into this thing and then there's outputs, what do you think the function is?
The black box theory.
It is a black box theory. Can you explain that a bit more?
My pocket. Vending machine.
A what?
Vending machine.
A vending machine. You bet.
Oh yeah.
All right, you have a vending machine. If you put in a buck, what could come out?
A soda.
A soda could?
Some change.
Some change, maybe, a water. What if you put in $2? Do you get anything different?
No. You get 2.
You could get 2. Is everything always a buck in the vending machine? Some things are different prices, right?
Like soda's 50 cents.
Soda's at 50 cents. So if you put in 50 cents, you know you're going to get a soda, right?
Yeah.
If you put in $1, you might get a water or a smart water or whatever, right?
Okay.
Or a milk or something, right?
I like milk.
Get the idea?
Yeah.
Okay. So a function could be nothing. So whatever you put in it, you get that back out. So you put in a $5 bill, you shake it up, a $5 bill floats out, right? There's not much to that
I
function.
know the time.
But if you put a 50 cents in a vending machine, something else different definitely comes out. Function is that. A function is a machine. You could put something in, you're going to get something out. Okay, that's what we're going to talk about today. It's a really abstract concept. So using a vending machine is a really concrete way of understanding what this stuff is. So what I want you guys to write in here is it must be a dependable machine. This is the best 2-word description I can come up with. A dependable machine.
Yeah, the vending machines are dependable, but then they're just taking money.
Right. So then isn't there a little sign saying, hey, if you don't get someone, you got to call this number, and then you get a or you go to the office and you get a refund. Hey, I put this stuff in, right? But if it works correctly, you expect something to come out, right?
Yeah.
A function is exactly the same way. If you put something in, you expect a certain thing to come out, and that's what a function does. Okay? In graphing, we have other words for them. In graphing, we call them x variables.
Right there.
Yep. And you get a y variable out of it. And there's always a bunch of them. The domain is not just one thing, it's many things. And the range depends on the domain. Now I'm going to use a really interesting example. Hopefully you guys will remember it forever. You guys are a function. Noah, yes, you are a function. What do you put in yourself?
Food.
Oh, what comes out?
Food.
You bet. If he eats something, what will always come out of him?
I mean, fluids, urine.
Well, no, let's just go with it. He eats an apple. Well, let's say a biscuit or a cookie.
I like biscuits.
What happens if I
Biscuit.
punch him in the
What
stomach?
does he get? What comes out for sure? If poop doesn't come out, what's going to happen to Noah?
Constipated.
It's going to explode.
That'd be weird.
All right. So you know for sure what's coming out depending on what you eat, right? What about the other one? What if you drink something? Noah drinks a glass of soda. What's eventually going to come out of him?
Urine.
Urine.
Pee.
Pee. What if he doesn't pee?
It's kind of weird.
Something's going to happen. He's going to break, isn't he?
Yeah, you probably need surgery there.
This game is
Okay.
gonna explode.
Does this not fit our definition?
How weird.
Aren't we a function?
Body.
If we drink, we will pee. If we eat, we poop. No doubt about it. It happens.
This conversation has escalated.
It has. I told you this would be a weird example, and hopefully this will remind you. Now, in science, you have types of variables. Do you guys remember those words in science? You can experiment. What kind of variables do you have to consider if you're doing an experiment in science class? There's words for these variables.
X and Y.
Independent and
Dependent.
dependent. Which one's independent, which one's dependent?
I don't remember.
The function makes dependent variables.
Wow.
So what's independent? What do you have control over? That's what independent is. You get control over the inputs. You get control over what you put in your body, don't you?
Not really.
Yes, you do.
No.
What if you're a baby?
Yeah, I think we're complicated.
Well, you're just being argumentative.
Well, you're in the home, you don't choose what you do.
So if you put something in yourself, you know what's coming out, right? Now, if you don't put anything in, what comes out? Nothing. So isn't this dependent on what you do?
Yep.
This is why this is the independent variable. So if you ever got confused about that in science class, there's another way of doing it. This is where math and science have the same idea. These are independent variables. And you should know all these terms. You should know the domain of the inputs, the x variables and the independent variables. You need to know all these. Because independent variables are all about the story problems. Based on the story problem, you should know what you have control over and what is coming out. This is dependent. Domain and range are strange words. They use them in math. Independent variable and dependent variable is used in science. And then these things, both of them use. So science also understands that independent variables are inputs, dependent variables are outputs, and if you graph this stuff, you have your x variables and you have your y variables, or your values. This is a lot of vocabulary to take in, but we'll work on this for a while. All right? Any questions so far on these words? Yes, Ryan? Oh, sorry. All right, any questions in general? Yep?
The y-axis and the x-axis.
Yep.
Did we take a test on there?
Not yet. You're going to see how it connects. And how it connects is this sitting right here. The x and y axis, if I say you put in a $5 bill and I don't know, how about 3 candy bars and a soda come out. I could chart that.
It's an overpriced soda.
That's what I'm talking about. That would be a real world example. Okay? What we're just going to focus on are just numbers. So I'll say I put in a 3, out comes a 5, and you plot that. I put in a 2, out comes a 7, I plot that. So we're just going to start simple. Talk about the more real world examples. Okay? Now, you guys, that's a function. Well, let me show you kind of pictorially what it might be. That's what it does. You put in something for x, it spits out a y. That's really what it means. So when we determine things in the real world and we want to make a prediction, let's say we discover, hey, you know what? Every time I do this, this happens. What happens 20 years from now? Well, I don't want to figure out 20 different times. I put a 20 in here, and then I figure this out. So that's kind of where we're at. This allows us to predict things. All right? So if I put in a, let's choose a number. Let's find out here.
7.
All right, if I put in a 7, what do I have to do with the 7?
By 6.
Have to follow order of operations, don't I? If I multiply it by 6, what do we get? 6 times 7? 42. 42 plus 5?
47.
All right. So we found out that if I put in a 7, I get a 47 out.
You read those?
Yeah, we'll just use your example.
Oh. Right.
Let's try something else. What's the easiest input in the world? 1. You need 0. 0 is the easiest one. What if I put a 0 in here? It's 0 and then plus 5. 5. That's fast, isn't it? That's why 0 is like the best one to choose always. 9?
Just do your finger trick, you're done.
Let's try something more challenging. Let's try a negative number.
-2.
Negative 2. Let's use a negative 2. I put in a negative 2, what do I get?
-12.
Negative 12 plus 5.
Negative 17. Positive 17. Negative
No,
17.
-7.
What's that?
-7.
Why?
Because you add. the
Because if you have a
positive.
negative, then you add a positive.
Yeah,
It's
that's
not
it.
negative.
Looks like that, right? And that's why it's really tricky. If you don't get that arithmetic, it'll just, and it's not going to be this. It's going to be that gets you. Okay? So that you got to know. You can use your add out prop to figure that out too. Let's try another negative number. Let's try an easier one. Let's try negative 1 once. You guys do it. You guys do it. Write something down, and then we'll verify. All right, what do we got for an answer?
-1.
Negative 1? You get it. You put in negative 1, you get a negative 1 back out. Really? Does that make sense?
Yeah, I would say our kid was negative 6. A negative 1 times 6 was negative 1. I mean, negative 6 times 5.
Oh, I got it. Never mind.
Yeah, it seems to work, doesn't it? Okay, so this is now no empty box, right? So Noah's example and off of Dylan's is like you put in a 5, you take the box, you get a 5 back out, right? You put in a 1, you get the 1 back. You put in a 10, you get a 10 back, right? That's a really simple function. Obviously, you can see this one's a little convoluted. It makes it harder when I give you this, and then you got to come up with the equation.
Yeah,
We go backwards eventually.
not bad.
It's more challenging for sure. All right, last example. Let's try one more. Since we got one more spot. 3, great. We put in a 3. You figure out what we're gonna get.
Yeah.
I thought we were working
Oh,
on
we
this
have
class.
See, Mariah's participating. Thank you, Mariah.
You are welcome.
Yeah, I know. Yes, Trevor.
26.
26.
23.
23.
22.
22.
Wait, hold on.
Well, we got a bunch of them. Let's go. Right?
Sorry, I.
Right?
Yes.
Okay, just making sure.
Oh,
So
yeah,
you can see
that's right.
sometimes it pays to kind of write it out. Sometimes you do it too much in your head and you lose track of it. It happens. What do you mean? All right. So get the idea.
Yeah.
Now, what's the domain of what we just did?
What?
What's the domain of what we just did?
Inputs?
Uh-huh.
7, 0, negative 2, negative 1.
You got it. It is all of those. Our domain is 7, 0, negative 2, negative 1, and 3. Those are the ones we chose. And you can see that it's not just one thing. It's many things. So domain is a set of numbers. And what's the range?
47, 5, -7,
We got it.
23.
47, 5, -7, -1, and 23. Now, you might be able, in the future, you might want to just be systematic about it. You might just want to go up each one. We went all over the place, right? It doesn't really matter, because if I were to graph this, they'd all fall in a straight line, no matter what I pick. Okay? But you make more sense of it if you're systematic. Let's say you go by ones or something. You know what I'm getting at? So the ones I typically want you guys to choose, unless it doesn't say, are these. Those are the 5 I want you to choose every time, unless I say. -2, -1, 0, 1, 2. Most of our functions, even all the way to algebra 2, all the cool stuff happens around 0. Because we'll go from straight lines to swoops, to the McDonald arches, to, you guys see sine waves? You ever see this kind of stuff? Yep, that's a sine wave. That goes into algebra 2, trig stuff. Okay? They're all functions. They're different functions, but they all obey the same function idea. So far, so good? All right. You guys go ahead put in your -2, -1, 0, 1, 2, tell me what the outputs are, and then write down your domain and range.
Of course.
Hey, did anyone notice a pattern?
Yeah.
What's the pattern?
So I'm by
It goes up by 7. Definitely. How did I know that without even having to look?
Because you've already done it.
I have, but I don't remember these from last year. But I did look at something specific and just used it.
3.
Well, it's
Trevor?
7.
On the inputs, when you add the inputs plus the 3, it just adds up to like 1, 2, 3, 4, and then if you times that by 7, that'll give you your answers.
Okay. Something even quicker. And he said it. Yeah, what am I doing every time?
Here, multiply by 7.
Multiply by 7. Okay? And that's the kind of pattern I'm going to have you guys start looking at. There's going to be a pattern to it. And you'll see the pattern better if you make this the same kind of stuff. -2, -1, 0, 1, 2. Every time, you'll see the patterns better. Here, were you going to be able to see a pattern when we did it all over? No, we're not. So you can be more successful by actually picking something and then going one up each time. And I do want you guys to throw some negatives in. You guys got to work with negative numbers because we're not all that great at working with negative numbers. We got to still practice that. Okay. So that's why I choose these 5. All right. What do we got for a domain? All right. Now, I noticed no one said from -2 to 2. Do you know why you can't say from -2 to 2? Well, how many different numbers are there between -2 and 2?
3.
A lot.
How many?
3.
Yeah, think about if you go into the points.
What's that?
If you go into the points, you got more.
Yeah, decimals, right? Can I do -1.5?
Yep.
Can I do 1/3?
Yep.
Can I do 0.587?
Yep.
How many are there?
Like infinite.
Infinite number between -2 and 2.
16.
Okay, we didn't actually choose them all. We just chose 5 out of those possibilities. So we got to write the 5 down. I know it's a pain in the butt, but it gets harder. So this is actually the easier idea. And then here you can't say you went from 7 to 35 because you didn't get every number in between. You only got 5 numbers from 7 to 35, so you actually got to write them down. Okay? So that becomes a big pain in the butt, but that's where we're at. All right? It gets harder, so we'll stick with concrete stuff first. All right, and that 4 problem, it's a little harder. An airplane has an altitude of 34,000 feet. Does anyone know what altitude means?
In the air.
Trevor?
How high they are.
Yeah, how high are you up in the air, right? Okay. So the pilot is getting ready to land and descends at a rate of 200 feet per minute. What does that mean?
Going down.
How much?
At 200 feet
200
per minute.
feet per minute.
Per minute. So after 1 minute passed, where should the altitude be? 200 less, which would be?
33,800.
That's right. So after 1 minute, we're at 32,800. Right? All right. So what happens when I have a 0 here? What does this mean? I
That's
haven't
when
gone down yet. So what's my altitude at this point?
34,000 feet.
34,000. All right. And it says make an input-output table for the first 10 minutes. The plane is descending in intervals of 2. So I've actually created all this for you. Later on, I won't create anything. You guys got to come up with this. So in this case, first 10 minutes, from 0 to 2 to 4 to 6, 8, 10, right? What happens in minute 2? Where is he at?
33,800.
No.
Oh,
Minute 2. Trevor?
33,600.
Yeah, I skipped one, didn't I? And that's the trick. That's why this is an F4 problem. It doesn't seem that hard, but because you didn't read really carefully, all of a sudden you got something wrong and you definitely knew what the heck was going on anyway. What's at minute 4? 200, yeah. So instead of going down by 200s, what did you guys just figure out?
Going down by
We're
400.
going down by 400s according to this table. So far so good? Tell me what you get at 10. What do we get? 32,000. Did everyone go ahead and go down 400 all the way? All right, what if I asked, what about in a half an hour?
It'd be like a lot.
I know. How'd you go, what if I said 30 minutes?
Maybe you're on the ground.
Maybe. Do you know how to calculate it? Or what would you do? Yeah, Trevor?
Well, at 10 you're at 30,000 feet, but then at first you're at 0, you were 34,000 feet, so then just take 2,000 feet off each 10 minutes.
Yeah, that was beautiful. For every 10 minutes, he's going down 2,000 feet, right? So at 20 minutes, it's at 4. At a half an hour, it's at 6,000 feet below, right? Which means take 6 off of 34, and you're left with 28. Make sense? But isn't that looking at patterns and figuring it out, right? And what if I said an hour from now, you could do the same idea, right? That's why if you know your math really well, you can zip through problems like that because you're seeing the pattern. Now what if I give you a bizarre one like 47 minutes? Yeah, there you go. You times that by 200 and then what? You're absolutely right. Where is she coming up with this 200 business?
It said it's descending 200 feet per minute.
Mariah's being really smart. She's like 200, well, times 47 then. That's 47 minutes worth of 200 meters, or 200 feet, right? But what do you do with that result then? Take it off of the, that's exactly what it is. And Mariah just did this. She plugged in 47, multiplied by 200, and took it off at 34,000 feet. It's exactly what you just did. Lovely. Yes. But that's the idea, right? Now do you see the connection between a real life problem and what we've been kind of doing here, the input-output stuff? Almost everything is a function in this world. Okay? And we use it. All right, let's flip it open. And Mariah just solve this. Notice that's the secondary problem. If you're able to come up with an equation from a table, that's really challenging. We're hitting that. We'll definitely be doing it later, but if people can do it now, you guys are well ahead of the game. Not easy to do. Nicely done. All right. A couple review things. Ours for review. What's this mean? I've done this before. Do you guys remember it?
It's a mistake with minus the x on both sides. Stuff like that.
Minus the x on both sides. I see you trying to get like y by itself, right?
Yeah.
Trying to solve. I don't need to solve this problem. Yeah, you plug in. What do you plug in and where does it go? There you go, that's right. You plug in -4 for your x, and you plug in 0 for your y. Right? That's what the ordered pair is. So now you can understand how I'm connecting an ordered pair, x comma y, with an equation. I'll write this out. My advice to you is always to do this step first. Always plug it in without doing anything. Because if you plug it in without doing anything, then you'll start seeing the double negatives and stuff. If you do it all in your head, you might lose track of these negatives. And then all of a sudden you're getting the wrong answer when it's not too challenging of a problem, it's just like you made some mistakes. What is -3 times -4? Well, positive 4?
Yeah.
Okay. And what's 6 times 0? 0. What happens when we have a number equaling a number? We've seen this before. What's that?
Infinite solution.
It would be considered an infinite solution because it's a true statement. All right? Is this a solution of this equation? Is -4 and 0 make this true? It's a solution. So we'd say, solution. Or you can like check it or something. If it was, we have done this before. If it wasn't a solution, you'd have to write no solution. Like it didn't equal. Like we had 5 equaling 12. That's definitely not a solution. So far so good? Think you got that idea?
I was supposed to the last one, there's no text for that, so what do you do for it?
Well, the function says y is 1. Doesn't care about anything else. Y is 1. So does a 3 comma 1 satisfy that y equals 1?
Yep.
It's a solution. It's that simple. Looks weird though, doesn't it? So in this case, you still plug in your 1 here and you're like, well yeah, that's true.
Hey, that would make my life easier.
Yeah, but it looks strange, right? So those are the ones that'll probably throw you for a loop. Try the one in the middle and see if you can come up with a solution or no solution on this one.
Yes, J.T. Burner,
It is no solution. No
Megan
solution.
Land.
That worksheet is due for tomorrow.